Welcome to I Didn't Know AWS SAM Could Do That. I'm Alex Wood. I'm a senior software engineer with the AWS Serverless Application Experience team. And what we're going to talk about today are a number of features in the AWS Serverless open source tooling space that are less well known that you may find come in handy. Which should complement some of the other talks you're seeing about serverless and serverless tooling. So we're going to look a little bit at some interesting customization options you have around building serverless applications. We're going to talk about interesting configuration techniques you can use to streamline your use of the AWS SAM CLI. We're going to talk about custom event generation to improve local testing, especially for asynchronous applications. And we're going to talk about some ways to do serverless log analysis directly from your terminal. So briefly, what AWS SAM and SAM CLI are is SAM is a AWS CloudFormation transform. So essentially, you can define inside your template that you would like to use serverless resources, and it provides you a number of helpful abstractions and is also open source on GitHub. The AWS SAM CLI is a command line tool that is open source as well. Both of these are generally available and operationally stable and kind of work together. So, as I said, together, AWS SAM and the SAM CLI provide an integrated development experience where AWS SAM provides a number of very useful abstractions over serverless resources and CloudFormation that help to really simplify a lot of common use patterns and really reduce the amount of templating code that you write. The AWS SAM CLI is a tool to help you create, build, test, and deploy those applications and provides you with a number of useful development lifecycle features. And these also provide templates and builders that work with all of the native AWS Lambda runtimes. So to start off with, we're going to talk about custom builds. The AWS SAM CLI build command comes with some best practice build processes. So for JavaScript, Ruby, Python, Go, Java, and .NET, it's going to build your serverless application and package it in a way that fits the best practices for deploying to and running on AWS Lambda. Another convenient thing about AWS SAM CLI builds is if you have things like native dependencies, so you're depending on native libraries in the operating system, you can build inside Docker containers that are similar in structure to the AWS Lambda execution environment. And this is really handy because if you are not using a Amazon Linux development machine, you may see some differences in behavior when you compile certain native dependency SOs. And so building inside a container will allow you to have compatible binaries with the AWS Lambda execution environment and provides a very convenient way to do those builds. So anyways, AWS SAM CLI's build provides you with a general best practice build process, but what if, and this is certainly a thing that can happen, what if I know a better way to build my functions? Like I understand the basic concepts, but I want to do builds differently than what is provided by default, or I would like to build for a custom runtime. So this is where custom builds with makefiles comes in. So as part of your SAM serverless function definition. And again, we're going to have links to getting started resources. So if you're not super familiar with SAM, bear with me for a moment, try out the examples, and then I think you'll find that you can follow all the examples we're giving here. But if you provide a metadata value on your function, you can specify a build method. In this case, you can say, rather than what SAM CLI's build would do, I would like you to build based off of a makefile that will tell you how to run. So in this case, for example, we're building a Go function, and we're saying, here are build flags and build settings, and then we're going to copy the generated bootstrap binary into an artifacts directory that is then uploaded to AWS Lambda. This can also come in handy for building layers for AWS Lambda. So one interesting feature of AWS Lambda is the ability to provide different layers that you can even share across functions. But of course, in many cases, you may want to build these. They may come with dependencies of their own. And so you can use these same makefile methods to, say, build a Python layer that you are then going to attach to different Lambda functions. So let's take a look at a practical example of this with a brief demo. So here we have a serverless source repo. When we look at the template, we'll see that we have the makefile build method specified. So rather than use the default Go build path, it's going to use what is specified in my Hello World makefile, which matches what we saw in the slides earlier. So with this makefile, when I go to run SAM build, it is going to use those makefile instructions. And you can even see inside the debug output data that it mentions the makefile build method in the output of the build. And then if I run a local invoke, you can see that the build was successful and we produce the example code. This is very based off of the SAM init Hello World example. So if you want to initialize such a project and try these build steps, you'll see the same outcome. Cool. So SAM CLI does provide really helpful built-in build instructions for Lambda runtimes that set up and properly package things to run smoothly in Lambda. But if you're using custom runtimes, if you are building layers, or you have special build instructions that you would like to specify that are different than the defaults, you can absolutely do that using a makefile that you provide. And if you're interested in learning more about this, our multi-talented developer advocate, Eric Johnson, has a series called Sessions with Sam, which has video examples. So next we're going to talk about AWS SAM CLI configuration. So if you've used the AWS SAM CLI before, you might be familiar with the SAM deploy -- guided command. And what that does is it asks you a series of interactive questions about things like a stack name you'd like to use, region you'd like to deploy to, and other such settings. And the advantage of using this is it will then save in a configuration file all those arguments you used, so that in the future you can just say SAM deploy with no arguments, and it's going to repeat what you've done before. This is really handy, and it has really simplified a lot of development deployment cycles, but we can take it a little bit further. So again, what we see here is that this is a shortened sample of what a configuration file looks like after you've done a guided deployment. And again, this is really handy, but why not other commands? Under the covers, this is implemented as default arguments into different SAM CLI functions. So for example, if you wanted to say, I am always going to SAM build using a container, you can specify that as a default argument, and then when you say SAM build, it's always going to add the use container parameter, which can really simplify. Like you can just say SAM build, SAM deploy, and not worry about remembering if you have all the arguments that you want to use. Additionally, you'll notice the naming of the profile here is default. One thing that SAM CLI also supports are different profiles as well as different configuration files that you can specify. So for example, if you have different stack targets that you want to deploy to, like different stack names that maybe have slightly different parameters or different regions, you can support that using different configuration profiles, and this works for any command. So let's look at a short example of how this works. So we're in a different project now, and you can see that we pre-populated with build parameters as well as a couple of different deployment targets, both production and gamma stages that have different buckets, different stack names. So if we say to build using production configuration environments, you'll notice we didn't specify to build into a container, but in fact it is building inside a Docker container. And of course, you can also use a default profile to not be specifying, but this will, you can switch back and forth between profiles as you go. So now we're going to deploy to a gamma stage, having built this, and you will see that it is using the different gamma targets, including the stack name. Now, this happens to already be up to date. So if we deploy using our production settings, where it is not currently up to date because it is a different stack name, you are going to see that the deployment then goes on to run and actually change resources. So again, this is very handy if you are trying development stacks in different regions. If you have parameters to your stack. So for example, you might have different settings for different stages that reflect in the parameters that you choose. And so this is a very handy way to deploy one, quickly deploy another, and not have to re-specify all of the different arguments that go into it. So we should see the creation finish here, and then that's an example of a completed deployment. And we're going to curl the endpoint, and we can see that the newly stood up endpoint is working properly. So again, what can you do with AWS SAM CLI configuration? So the most familiar use case is with guided deployments. You can save that configuration for reuse, and guided deployments do support specifying different files and profiles, so you can use guided to populate each one of those. And it allows you to support different configurations for different profiles or use cases. And it's also really handy for providing default arguments into other SAM CLI commands that you use, which can really reduce the amount of time you spend putting in redundant parameters that are going to be the same every time you're running a command. So it can really simplify your development lifecycle for common use cases. All right, now let's dive into custom local testing events. So AWS SAM CLI provides a number of methods that help you with local testing. So the three testing modes that we support are invokes, which run a single instance of a single Lambda function, start API, which starts up an API gateway simulation on your local machine and then routes invocations to different Lambda functions as appropriate. We also have a start Lambda testing mode, which will simulate the Lambda API itself. So if you use the AWS CLI or AWS SDKs to call the Lambda invoke command, you can point that to your local endpoint and see those APIs working with local versions of your functions. And you'll notice Start API is very helpful for things like testing API gateway web applications. But then the question becomes, let's say that I have asynchronous Lambda functions that are based off hooks like SQS, SNS, or others. Start API is going to provide web integrations with some of the parameters, but how do I deal with effectively testing my asynchronous events locally? And this is where the SAM local generate event command comes in. So what we have here on screen, the JSON below is less important. The emphasis here is on the generate event SQS receive message command. So we have a number of different service integrations and possible events, which also include options that you can specify to customize different values that you care about, and you can produce a JSON file that you then go and edit as desired. But what this does is it gives you a very quick path to validly formatted event inputs that you can use to simulate, are you correctly handling the shape and structure and contents of these events? So let's take a look at a demo to see generating events in action. So we're going to start with a SAM local invoke command. And one thing you're going to see here is that we actually have an empty event in this case. We haven't specified any particular event. And since we're logging out the event that's created, we're not going to have very valuable output. So let's actually generate an SQS event for this Lambda function that implements SQS integration. And you can see that we specify a body. Also worthwhile if you check MD5s is our generate event for SQS will actually generate an MD5 that matches the body contents that you generated. So now if we SAM local invoke with the SQS event, what we find is now we're actually logging that full event. And so if we wanted to test different interactions with different parts of the SQS input in our local function, we are now able to do that. So again, AWS SAM CLI local testing is really useful for fast iterations in container environments similar to Lambda. So if you're developing a function, you're making some small changes, you want to make sure that it's working properly, it's a really handy way to quickly get feedback without deploying. And the generate event command is really helpful and sometimes overlooked when it comes to testing asynchronous integrations or particular service integrations outside of the Start API use cases for things like API Gateway and web functions. So it's a really useful thing to add to your testing repertoire. It can even be useful for writing unit tests, for example, because it's just going to generate a file that you can do with whatever you please, and that file is going to match the format of messages that you would get in production Lambda. Next, let's talk a little bit about the log analysis use case. So AWS Lambda functions in production output their log events and execution metadata to Amazon CloudWatch logs. So you'll get both the logs that are running from your function, as well as some pieces of logging that come from the Lambda execution environment itself. And if you've deployed Lambda functions before and gotten an error that you couldn't understand, you're probably familiar with logging into the AWS Management Console to look at the logs that were generated and try to diagnose what happened with that iteration of your function, where the errors were occurring. Well, can we do this from the command line? Do we have to log into the console to see what is happening with our function, including in real time? And the answer to that is yes, we can do this from the command line. So this is where the SAM logs function comes into play. So with SAM logs, I can specify the name of my function as defined inside my stack. So in this case, we have my serverless function. If you've deployed SAM applications before, unless you explicitly provide your Lambda with a specific name, you're going to get an auto-generated one from CloudFormation that often has a little bit of a hash coding on it, which is useful for deploying the same stack multiple times without hitting naming collisions. But it can be a little bit inconvenient if you're trying to pull logs. So one thing that we will do is if you specify the stack name and then the resource name inside your stack definition, SAM CLI will figure out for you the appropriate log group to pull from. So if you say SAM logs with the name of your function and the stack, it'll pull a sampling of your most recent logs. Another handy piece of functionality is you can do live log tailing. So you can open up a terminal, you can specify the name of your function, you can specify the stack name that you deployed to, and you can say --tail, and as you invoke your functions, you can see the logs coming out of it in real time, which is really handy for, I'm trying to test a few different types of inputs and try to see what's causing this failure or this behavior I'm seeing. And you can just have a live set of logs coming from your application. You can also do time ranges. So if you had a temporary failure event, say in a production stack, and you're trying to figure out what the cause of that was, you have the ability to say, here's a start and end point, including in relative timestamps, and it can fetch all of those logs for you and nothing else. So you can just focus on the key times that you actually care about. You also have the ability, and you can stack this with the previous arguments, to filter. So, maybe I generate a lot of logs in my particular function, and I just want to figure out like error statements or fatal statements. I want to just get to like what was causing that failure that I just observed. So the SAM logs command also supports message filtering. So I feel like I recall recently that we were talking about something about repetitive arguments, like what we were just showing here. And there's the famous quote, use SAM config files to simplify repeated command arguments, which I think was something that I said a few slides ago. So what does that look like in practice for something like SAM logs? So we've gone back to our previous config-based example here. We are running some curl commands against an endpoint, and we want to see what logs were generated. So again, if I look at my SAM config, we can go down and see that on the Gamma stack, we have parameters specified that go into our logs command, so that we're not going to be specifying the stack name or region. I can just focus on which function do I want to see, and which environment am I comparing against. So when I run SAM logs, I'll get the most recent logs for that stack, for that function, and I'm focusing mostly on parameters that actually matter. So I can look at different functions, or I can put in different values for what time range do I want to look at? Do I want to do a live tail of my logs? So it really reduces it to only the parameters that might actually vary, rather than any and all parameters every time I run. All right, so let's wrap up what we've covered today. So again, AWS SAM and the AWS SAM CLI together provide an integrated development experience. So AWS SAM is really useful for simplifying your application infrastructure when it comes to common serverless integrations. And the AWS SAM CLI is really handy for being able to create these applications, to build your source code, to do local testing, and to handle the packaging and deployment of your AWS SAM built applications. And again, for building AWS Lambda functions, for all of these natively supported runtimes in AWS Lambda, you have built-in steps that are going to build them in a way that is easily compatible with the Lambda execution environment, so that you don't need to think about those details. But if you do know a better way to build your application, which is not uncommon, you may have special build flags you want to include, special steps, you have the ability to bring your own build process. You're not limited to what the AWS SAM CLI has built in. The AWS SAM CLI also has those configuration files that help you to simplify your commonly used command patterns. And again, you have the ability to split across different files, to split across different profiles, to better organize your development environment as you get a larger number of stacks or regions or targets or parameters that can go into your templates. And that works for functions beyond simply deploy through the guided command. Again, through to local testing, there are a large number of events that you can generate that really help to simplify the experience of simulating service integrations using those generated events. And finally, you don't necessarily need to log into the console if you want to debug that function you just deployed. Again, the SAM logs command makes it really quick and easy to log dive in that application you deployed directly from your command line on the same terminal that you've been deploying from and developing on. So where can we go from here? The biggest thing is just to go build. All the examples that we did today, you can create and run in just a few minutes. A lot of them are very small deviations and changes from examples that you can interactively create by starting with the SAM init command in the AWS SAM CLI. So definitely encourage you to look at the AWS SAM developer guide, which if you are unfamiliar, if this is your first experience and we're going straight into some of the underappreciated parts of SAM and the SAM CLI, go check out Getting Started in the developer guide. Build and deploy an application, and then come back and try some of these techniques out. There, again, is a wonderful set of interesting sessions with SAM videos that you can watch that dive deeply into these and other topics that you can explore. And again, feel free to reach out to share any questions that you have, any feature requests, or honestly, like if you watch this talk and build something interesting or it solves a problem that you have, we definitely love to hear about that as well. So definitely feel free to reach out. So thank you for watching this talk. Again, I'm Alex Wood, and you can find me on Twitter at AlexWWood. So I'm more than happy to hear about your feature requests, issues, or just to hear about something that you've built. So thanks for watching this session, and remember to complete the session survey. Thank you.